Welcome to my calculus class. Today we're going to be looking at the gradient and equation of a tangent. So allow me to take you back to coordinate geometry where you are finding the gradient of a straight line, say AB. All you had to do to get your gradient was get the change in y over the change in x. For a curve, however, say I have a curve of this sort on my x or y plane. If I get this point here, let me call it A. If I draw a tangent touching that point there, if I find the gradient of this line touching this graph at this point, I have my gradient, say M1. If I look at another point, point B, and draw a tangent touching the curve, so it has to touch the curve, touching the curve at B, let me have that one as our M2. Though these points are on the same curve, you'll find that they actually have different gradients. So in a curve or on a curve, the gradients are different with respect to a point where you are looking at or where you've drawn your tangent. So since the same curve has different gradients, we need to find a formula which will work to finding the gradient of the curve at any given point. Say if I choose this point here and I choose this point here, I can just get to substitute my values in one equation of the gradient for this curve to find that gradient. And that gradient function is our dy dx. So given any equation of a curve, to get the gradient of that curve at any point, you just get the derivative, differentiate it, that will give you the gradient formula. So what do you do with that gradient formula? If you want to find the gradient at the point A, all you have to do is substitute the value of x at this point A in the dy dx to get the gradient at this point. And if what you have to find is a gradient at the point B, then it just means you substitute the value of x at the point B in your gradient formula or in the dy dx. Note that the tangent, that's just the line touching the curve, not intersecting, but simply just touching the curve. So how do you find the equation of the tangent? So I've written down a few steps here. The first step is, if in the question given to you, they've only provided you with the x coordinate only, before you get the dy dx, find the corresponding value of y. Substitute that x in your equation given in the formula, in the equation, find the corresponding y. If you already have x comma y in full, then there's no need to go through step 1, you go straight to step 2. So now that you have the two coordinates x comma y for the question given, you find the derivative of that curve that you have been given. Then after you do that, substitute the value of x in the dy dx. And after you do that, this substitution will give you the gradient of the tangent. Then you go straight to step 4 now that you have the gradient and the point that you have been given or have calculated in step 1. You substitute in your 1-point formula to help you find that equation of the tangent. And after that, you make y the subject of the formula. So let's look at questions that make use of those 5 stages. It says find the equation of the tangents to the following curves at the points given. So we have the curve, let me call this one A and B. So for A, in A, our dy dx, considering we've already been given x comma y in full, is going to be equal to 2x. So to get our gradient, m1 is equal to 2 times, we substitute x with the value of x in the coordinate given, and we've been given 2, so we have 2, and that will give us 4. It means the equation in A has a gradient 4. It means It means our tangent for question A has a gradient 4. So now we have the gradient, which is m is equal to 4, and we've been given the coordinates 2, 4 through which the tangent is passing. To get our equation, we're using our 1-point formula. So we have y minus our y1, which is 4, is equal to m, which is 4, brackets x minus x1, which is 2. And that will give us y minus 4 is equal to 4x minus 8. Like terms together, or we make y the subject of the formula. In the final stage, we have y is equal to 4x minus 8 plus 4. And that will be 4x minus 4. Therefore, that's our equation of the tangent. Then we come to B. B says y is equal to 9x minus x to the power 3. So we get our dy dx, and that will give us 9 minus 3x squared. And again, we get the gradient by substituting the value of x given in the coordinate. So we have m is equal to 9 minus 3 and 3 squared. So we have 9 minus, this is negative 3. So negative 3 squared will give us positive 9, and 9 times negative 3 will give us negative 27, and 9 minus 27 will give us negative 18. So we have the gradient. So using the 1-point formula, you'll find that our equation of this tangent passing through negative 3, 0, y minus y1 is 0, so it's just as good as leaving it out. Y is equal to negative 18 brackets x minus, our x1 is minus 3, so this will be positive. And then we have negative 18 x minus 54. So this is the equation of the tangent to this curve at the point negative 3, 0. So you try out this question and show that your answer for the tangent at the point 2, 4 is y is equal to 10x minus 16. Thank you.